Our next company is Winterhawk Well Abandonment, and David Yeager. We look forward to your presentation.
Just got to find it again. In here, done. There it is. Good afternoon, Dave Yeager, President and CEO of Winterhawk. And I took over this company from helped my brother-in-law, Dale Coons, is the inventor. He's been on this project for several years. This is what I call the $1 million bumps. This last year, we ran this tool in the hole for the first time. And what we've done is these are 4 expansions inside a casing of a producing well. This is at 192 millimeters. So I'm going to talk about the vent flow challenge, casing expansion technology, our pesting program, our slim hole development, and this has a global applications. Here's how cement gas wells leak over time. Everybody's heard about surface casing vent flows. Over time, cement squeezes, wears down. There's channels occur along the outside. You get gas migration into the near surface aquifer, into the ground, and you get a surface casing vent flow. Here's a Society of Petroleum Engineers cross section to show you what happens. They've injected foam at the bottom over time. Cement shrinks. A crack as little as 3% can cause a leak in the casing. Here's a piece of casing. I guess casing has historically been seen as a barrier between the inside and the outside of the well. One day my brother-in-law came over for dinner and slapped this on the counter and said, "What do you think of this?" So now we're using casing as a remediation tool. I call it control casing expansion because we don't materially affect the internal diameter. We don't put any holes in it. We don't overstress the steel. So here's a before and after. Here's a wellbore that's leaking. In this case, we've got gas migration up a microannular channel between the casing and the cement. It could be elsewhere. We come up above the source of the gas, reform the cement using casing expansion, and shut off the leak. Here's how the mathematics of it is. How much do you have to expand it? So here's I'm going to put this in English because because that's what I do. Is 7-inch casing at 8 3/4 hole. If we expand the casing by 3.2%, we shrink the area of the annulus by 12.9%. If we expand the casing by 7%, we expand the area by 26.3%. So instead of cement squeezing, where you're trying to push fluid up the channel, we simply squeeze the channel shut. Here's the tool itself. It's a series of hydraulic rams. This is 23 rams in series. We introduced 4,000 PSI at the bottom end. We're about to do a test. Here's our first run in the field a year ago. Here's the before of our elastomer, and here's our after, and here's that same piece of casing afterwards. So it's again, we turned 4,000 PSI to 440,000 tons of upward pull. As you can imagine, you need a little juice to bend pipe like this. This has the same impact as an external casing packer. For those of you in the wellbore completion business, they would be familiar with running an external casing packer with the production casing to stop interzonal communication down the hole or problem areas. What we do is the same thing as an external casing packer after the fact. Where to put it? It's a bit scientific. We resume all the well logs. We use cement bond log. We need the open hole logs. We will run a gas identification log. Here's the first time we ran the tool last year. We went to 547 meters. You can see these dents on a caliper log where we achieved expansion of 5.9 meters. More importantly, on surface, during real-time monitoring, we did a 1-hour buildup before the event. Here's our bumps. We never got back to that level again. All subsequent 1-hour buildups were at a lower level. A few weeks later, there was a gas zone with water in it, or a liquid fuel gas zone at the bottom. It disappeared. We shut that off, never to come again. Here's another example from 290 meters. Like all new technologies, we had some teething pains, but in this particular case, you're seeing expansions of anywhere from 9 to 15 or 16 centimeters. It really depends on the casing, the size, the weight, the grade, and what we're up against. Here's a job we did just late last year. This is 6 dents at fairly close to surface. This was AER approved. This were bubbles in the well. They can be as annoying as a high volume one. We put these 6 dents in this well. The well has not leaked a bubble since. The breakdown of the casing sizes, according to AER, here's the production strings. We're in 7-inch pipe today. About 16% of the wells are 5.5 tool is under development. The largest market is 4.5. That particularly the sheer number of well bores down south. Well, we've been experimenting with multiple intervals where we're trying to increase the surface area. So here's what we call the 3-stack tested in a shop. Here's a 2-stack. Here's the 5.5 tool with the same thing. What we did just last week on Friday in our Lloydminster shop, we worked with Tier 1 Energy Solutions. Here is a piece of 5.5 casing where we've seen expansions averaging 12 millimeters or 8.7%, where the values are untouched. Going back to my mathematical model, this will shrink the area, the cross-sectional area of the annulus at this interval by something like 20%. Here's the same tool with 7-inch casing, and here's a piece of casing. In this particular case, we've got 6.7% expansion, about 12 millimeters or half an inch, and the values are untouched. The idea of putting these bumps closer together is to achieve radial compression of the cement off the shape of the curves. We're about to working on a test well right away. We're going to run the triple stack as soon as possible. It can be wireline deployed. Ultimately, our partner for 3 years is Tier 1 Energy Solutions. Here is a 4,000 PSI electric downhole pump. We're trying to get a little better understanding of its behavior in the well, but it will be run on wireline. Here is the GHG reductions shutting off a casing leak using conventional methods, which is perforating truck, wireline unit, cement, blender, versus going out with a wireline truck. We estimated 95% in GHG reduction during the execution process. So basically the message here is Wellbore casing is more than a barrier. It's now a remedial tool. A growing problem. There's 10,000 reported leakers in Alberta alone. There's hundreds of thousands all over the world. We need new methods to do this. It's this is truly novel. I've been in the business a long time, and I believe it's applicable to every wellbore in the world. Here's how to find us if you need us. Our website, just key it in. I can't speak any more quickly than that. Thank you very much.
All right, well done, David. Woo.